we are moving on to putting some more tools in our toolbox here. 3-2, we did the half angles, and we learned some more theorems and some more rules for that. We're going to add some stuff onto that today with our double angle and power reducing, half angle. I don't know if we'll get through all this today. We'll see how far we make it. You don't even know this lesson yet. All right, so number of basic identities follow the sum formulas for sine, cosine, and tangent. Sorry, that's what we did. The sum and difference. Today's the one, double one half. All right, but for this one, the first category of identities involves double angle formulas. So the double angle formulas are as shown. Now be careful when you look at that. The sine of 2 theta, you cannot rewrite this as, so the sine of 2 theta is not 2 times the sine of theta. Okay, that's important to notice. You can't just take this 2 and bring it out front. It doesn't work like that. All right, it's paired with that angle. I'm pretty sure we talked about that at one point before. All right, so you can't just pull that out. So there's more to it than just that extra 2. That 2 is going to be 2 times whatever that angle measure is on the inside. So we have the sine of 2 theta. It's going to be 2 times the sine of theta and the cosine of theta. So we have to apply a cosine in there with that one. Cosine of 2 theta is going to be cosine squared minus sine squared of theta. And then the tangent of 2 theta is going to be equal to 2 times the tangent of theta over 1 minus the tangent squared of theta. All right, so those are the ones that you have to apply to that. Can't just bring the 2 out. You have to apply other parts to it, other trig identities. All right, so let's use this once. So we want to use the double angle formula to find the exact values. And we're going to use the triangle. We're going to say if sine of theta is equal to 5 over 13, and it's in quadrant 2. Okay, that's the triangle we're going to use for this problem. And we are going to find sine of 2 theta, cosine of 2 theta, and the tangent of 2 theta. It's in quadrant 2. It's actually quadrant 2. All right. So our triangle for this is going to be in quadrant 2. I'm going to go ahead and draw that guy. All right. Now, we know that the sine is 5 over 13, right? What's the relationships for sine? Opposite over hypotenuse, correct. All right, so my opposite side is going to be 5. Hypotenuse is going to be 13. Now I'm still missing one side here, right? This is my x side. Now I can use Pythagorean theorem. If I use Pythagorean theorem, what am I going to get here? It's going to be 12. Now, what's something special about that 12 because it's in quadrant 2? It has to be negative, correct. All right, so that's going to be the triangle we use for all 3 of these problems here. Sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. All right, let's go first with the sine. So the sine of 2 theta, I have to apply the double angle formula that we have above. So this is going to be equal to 2 sine of theta, cosine of theta. That's equals. A little better? All right, so now let's just start plugging in stuff we know. We know what the sine and cosine is. So I'm going to have 2, what's the sine of theta? 5 over 13. What's the cosine of theta? Good, negative 12 over 13, which is adjacent over hypotenuse. All right, then just simplify from there. So multiply across the tops. 5 times 12 times 2 would be 120. Multiply 13 times 13, that's going to be 169. I don't know about you, but I don't think that goes any further than that, does it? I think we're stuck. All right. I won't simplify. That's not a very pretty answer, is it? That's not very satisfying. All right. Questions on that one? We didn't do tangent yet. We're gonna do cosine next. All right. So that would be the sine of 2 theta for that given scenario. All right. Let's move to cosine. Cosine 2 theta. So cosine, what's my formula for it? Cosine squared minus sine squared, right? So cosine squared of theta minus sine squared of theta. And that's going to be equal to, well, what's just cosine of theta? Negative 12 over 13. Now, because it's a squared, we have to square that. Minus sine squared of theta. Well, we just found that sine was 5 over 13. And we have to square it. All right, so now we square the top, square the bottoms. So what's 12 squared? 144. 13 squared? 169. Minus, what's 5 squared? 25. 13 squared? 169. So we're in good shape here because we all have a common denominator, right? Right? So then we add them together. We'll subtract them. What do we get? 119 over 169. There we go. With me so far? Yeah? All right, let's knock out tangent. So we're going to knock out tangent. We'll have one of each, and then I'm going to give you guys one to try with the same scenario. Okay? Well, a new setup, but the same thing. You're going to find the same three. All right, so then the tangent of 2 theta. Tangent is going to be 2 times the tangent of theta over 1 minus tangent squared of theta. Okay? So, what is tangent in this triangle? 5 over 12. Negative 5 over 12. Okay? Well, 5 over negative 12. Same thing. All right? So I'm going to have 2 times negative 5 twelfths over 1 minus negative 5 twelfths squared. All right, so then I'm actually going to end up with a fraction over a fraction here of negative 5/6 over 1 minus 25 over 144. This fraction works fun here. That's going to be equal to negative 5 over 6. Bottom common denominator, I'm going to have 144 over 144. So 144 minus 25 is 119 over 144. Then I'm going to have to flip it up. It's negative 5/6. It's going to be times 144 over 119. What's that? Okay. And then I multiply that. I can cancel a little bit of stuff out here. Well, I could cancel a 6 between 6 and 144. So then on top, 6 out. 144 divided by 6. 24. Okay, so that's going to leave me with negative 120 over 119. Ugh. Huh? Questions? Anybody? What's that? This one here? Right here. So this is 144 over 144. 144 minus 25 is 119. Okay? Questions?
That's it. I just get ugly numbers.
You got ugly numbers on this one. All right. So, flip to the back of your paper. Should have extra room. For some reason, it printed one-sided. So, you have that as an example. I'm going to have to erase mine here. At least the work. Okay? I'm going to give you another scenario. I want you to find the same three things as what we just did here. That'd be nice. I won't give you any roots or anything. I might. Maybe, maybe not. All right, so I'm going to tell you, I want to find the exact values of those three if, say, the tangent of theta is, let's go 3/4, and it's in quadrant 3. Okay, so if the tangent of theta is 3/4, our triangle exists in quadrant 3, I want you to find sine of 2 theta, cosine 2 theta, tangent of 2 theta. I'll give you about 5 minutes to do that. So, first thing, we're in which quadrant with our triangle? Quadrant 3, so that's bottom left, correct? My triangle would look like that. Now, we have tangent, so tangent is what two sides? Opposite and adjacent. So we're going to have 3 and 4. Now, what's one thing we have to keep in mind with our 3 and 4 here? They're both negative, aren't they? Okay, because the 4 is left, the 3 is down, so they're both going to be negatives. So then I use Pythagorean theorem. We'll realize that this is a Pythagorean triple, so what's the hypotenuse here? 5. All right, so sine of 2 theta. This one here, apply the double angle formula of 2 sine of theta cosine theta. So I have 2 times sine of theta. What's the sine of theta? Negative 3/5. Okay, what's the cosine of theta? Negative what? Negative 4/5. Okay, is that it? And we just multiply it through. Multiply the tops. You have 2, 3, 4. You have positive 24 over 25. That sound right? Who all got that? Okay. Second one, cosine. We have cosine squared. So the cosine, we already talked about that. That was negative 4/5 squared. Minus, what's the sine again? Negative 3/5. Okay. So I square the top, square the bottom. Looking at 16 over 25 minus 9 over 25. Agreed? 16 minus 9 is 7. 7 over 25. How many people got that one? All right. 2 for 2 so far. I like it. Now, last one, tangent. So this one here, I'm going to have 2 times the tangent. Well, we already have the tangent. That was 3/4 over 1 minus the tangent squared. We're looking at that, right? So on top, I have 6/4 or 3/2. 3/2 over, I'm going to have 1 minus 9 over 16. Okay, so then 1 minus, I'm looking at 16 over 16. So that's going to be 7 over 16. Flip it up. That's giving me then 3/2 times 16 over 7. 1, 8. I think that's all I can cancel, right? 3 times 8 is 24 over 7. How many of you guys got that one? All right. All right. If I remember correctly, I saw those answers quite often. That's not bad.
Are we allowed to simplify them?
As in, like to make it a mixed number? Yeah, I'd be fine with that. You don't have to, but you can do that if you make it feel better. What's up, Woodring? Uh-huh. The numbers become negative.
Like for tangent, when you look at it, you have to positive.
Yeah. Well, this one here, this would be negative over negative, right? So I just roll with it. Yeah, you don't. If it's a double negative, you don't even have to write them in there. Okay. All right. Any questions with how we did that stuff there, guys? All right. Let's move on to the next one. So next thing, using the double angle formula for tangent to find an exact value. This is just kind of an ugly one, but it gets really pretty nice, or gets pretty quickly. So we want to find the exact value of, that's an E. We want to find the exact value of 2 times the tangent of 15 degrees over 1 minus tangent squared of 15 degrees. So this is essentially already written in the formula form, isn't it? We already applied this from the tangent of 2 theta. So really, we need to work backwards. Okay? So this is given to us in this form right here. All right, so we work backwards from there. Because it's in that form, now I have that tangent would be 2 times 15 degrees, right? So I was able to simplify that by essentially the inverse of the double angle formula. Now 2 times 15 is what? 30. Tangent of 30 degrees. You find that puppy on your unit circle. What's that going to be? Root 3 over 3. Great. Okay. So root 3 over 3. You have root 3 over 2 over 1. No. Root 3 over 2 over... Crap, what is it? Let me make me pull the unit circle up. Okay. So we have y over x for that one. Okay. What's the y value at 30 degrees? What's the y value at 30 degrees? 1/2 over root 3 over 2. There we go. 1/2 over root 3 over 2. That's the tangent at 30 degrees, right? Flip it up. Okay? So you have 2 over root 3. Right? Okay, boom, boom. 1 over root 3. Multiply by root 3 over root 3 to get the radical at the bottom. Root 3 over 3. Leave me now, Coop. Tangent is y over x. Sine is y. Cosine is x. Tangent is y over x. Okay? All right, questions on that one, guys? Okay. Now, moving on still, there is a couple different ways you can see the double angle formula for the cosine of 2 theta. All right, there's 3 of them. Okay, so there's multiple ways you can look at these. Let's do a really, really ugly but pretty identity here. Okay, we're going to use some of these. So we're going to do a cosine of 3 theta is equal to 4 cosine cubed theta minus 3 cosine of theta. Doesn't that look fun already? Huh? All right. So first off, let's deal with that left side. This is I know someone's going here. Wait a second, Mr. Thomas. Everything you're doing is cosine of 2 theta. Where the heck do we get a 3? Right? Plus 1. Okay. Yeah, we added 1. So let's break it down. Let's go cosine of 2 theta plus theta. Now we have, don't we have the sum formulas that we did yesterday or 2 days ago? Oh yeah, oh yeah. So the sum of cosine is cosine of the first, cosine of the second, plus sine of the first, sine of the second. Right? Remember that? So let's replace. All right, this is getting fun. I'm getting excited. Can you tell? All right. Cosine of 2 theta times the cosine of theta. This is just the addition rule for cosine. Minus sine of the first times the sine of the second. Boom. I'm just showing you what I'm doing. Right here. Boom. No. Right here. Boom. Right there. You guys complain a lot.
Well, you know what the people ask it, see that, be like, oh my
Okay.
gosh.
So we have 2 cosine theta minus sine 2 theta sine theta. Okay? Now I also have my cosine 2 theta, which we did today, right? And I have my sine of 2 theta, which we did today. Let's just deal with the cosine right now. So I'm going to replace the cosine. I'm going to replace this guy with 2 cosine squared of theta minus 1 times the cosine of theta. Where did I get the 1 at? Used it right here. Right there. Boom, boom. Okay? Now I have this sine of 2 theta on the right side. I'm going to apply this guy. Okay? So that's going to give me minus 2 sine of theta, cosine of theta, sine of theta. All right? Now, let's distribute that left side. I'm just plugging and chugging here. Plugging in the different values, the different formulas. You had Dr. Roth, didn't you? You haven't? Don't worry. She'll say plug and chug every single day. Okay? Never made me uncomfortable. All right. So I'm going to multiply 2. Now I have the cosine cubed of theta minus the cosine of theta. Over here I have minus 2 sine squared of theta, cosine of theta. I'm getting there. Because I needed a cubed. All right. I'll slow down. I'll hold for a second. All right. It does. I use this formula right here. What's for this? Why does it have a sign in it? Then just add it.
You did.
Where?
You subtracted it. Like, why does that even work?
Up here?
There's no cosine.
What happened to that extra sign?
There's no
It
sign.
got put in as sine squared.
Oh,
That part I get.
Honestly,
Oh,
I'm just
Where the hell
confused
did
how
the
you're
cube come
getting
from? It just appeared out there.
because we multiplied 2 cosine times cosine.
All we did was.
Wait, so he just distributed the cosine.
Now, guys, all we did was rewrite terms with formulas and theorems that we have. That's all we've
So
done.
do you believe it?
Yes, I believe it.
Why?
Because the theorem has been proven time after time after time after time after time. I'll get your name. All right, so this, that's the problem. Yes, we're verifying.
And then the sine theta on the right side.
Now, here I distributed to get 2 cosine cubed of theta minus cosine theta. Distribute the cosine through.
Oh, okay. So carry over.
On the right side, over here, I multiplied this and this. I have 2 sines giving me sine squared. Okay? I just rewrote it. 3 is 2 plus 1. Yeah, I'm just on the left side. Yeah. Okay. Now, let's keep going. So, now, I see this sine squared over here, because I need to get rid of sine somehow, don't I? Look at my final answer. I have cosine and cosine only. But I have a sine squared. What's sine squared equal to? 1 minus the cosine. Okay? So this is going to be 1 minus the cosine squared of theta times cosine of theta. We're getting there. We're getting there. All right. Now, I can distribute that with the parentheses that I just had. I distribute that. I have negative 2 cosine of squared of theta. So all I did is I distributed the 2 here, and I just brought it out front. All right, then I distribute the 2 again. I have a positive 2 cosine of theta. Oh, I got that backwards. Cosine, negative 2 cosine of theta, and cosine 2 cosine squared of theta. All right, I took this negative 2. Negative 2 times 1 is negative 2, and then I brought this cosine here out with it. I just did that in one step. Okay, almost done. Right here, negative 2 times 1 is negative 2, and I brought the cosine out front with it. All right? No.
I don't know, this feels kind of illegal. I think you should get points.
It's all legal. Do you want me to put an extra step in there?
Hey.
I can put an extra step in there
Where did
if you don't believe me. All right, fine.
No, listen.
Huh?
Stop.
I'm showing you.
Did two cosine
I'm showing you.
Nah, put the extra
2 cosine cubed of theta minus the cosine of theta minus 2 plus 2 cosine squared of theta. And then this is all times the cosine of theta, right? It's out here. There's nothing to subtract. Huh? Now, this here is all together, all right? This stuff here is all together because I just distributed this, correct? All right, so I'm going to bring this cosine out and put it with the negative 2. Cosine theta minus 2 cosine of theta plus 2 cosine cubed of theta. I didn't put that cube. I just had a square there before, so I just distributed again. Okay? My fault on the cube. Now, combine like terms. Cubed, cubed. 4 cosine of cosine cubed of theta minus here and here minus 3 cosine theta. That's what I was asking for.
I don't. I'll read.